Good morning. I'm Jeremy Waugh. I'm here to present to you my presentation on GIS implementation for Pinellas County. And what I hope to present or show you through this presentation is the benefits that GIS implementation can have on our asset management program as a whole, as well as make our workflows and work systems more efficient. I will switch over to my presentation. I hope. GIS implementation for asset management. Presenting to you, Mr. Scott, as well as your team here of corporate directors. This report studies the benefits and the risk associated with the implementation of GIS as a platform for asset management. I'm also going to look at and explain kind of our historic workflows and our legacy software that we've been using historically. When we combined our departments from all the different engineering sections and maintenance sections into one unit, we carried over a lot of legacy workflows and systems. My goal is to show you how GIS platforms can combine all of those systems into one efficient mechanism. I wanted to talk about different types of GIS systems that are ready out of the box that you can buy at a computer store or a software company, or we can hire a consultant to come in and write a specific software for us, and I'll talk about the benefits and risks associated with those two options. And eventually show you how the county services will be increased to our customers and citizens. A little history: we formed the DEI, Department of Environmental and Infrastructure, from 5 or 6 different divisions within the county. You had the roadway traffic controls, signals, along with the public works that built the roadways and the stormwater, and they maintained the right-of-way. And then you have our utilities, the water, sewer, and the treatment plants. All those were combined into one units, including the customer services arms, the engineering arms, the maintenance arms, the construction management teams, the survey department, the GIS department were all combined into one big department called DEI. When we did that, each department had their own management style, their own workflow systems, their own asset management programs, how you took care of the roadway, the sidewalk, the curb, the hydrant, the utilities, etc. These systems were all independently implemented originally, and they don't talk to each other now that we're combined. So we need to find a platform that puts all of those systems together and talking to each other to really get the benefit of a combined department instead of just acting like sub-departments or silos within a master umbrella. Where we're at today, each department has its own historical databases that go back 15, 20, even longer number of years on when parts were ordered, how old is the hydrant, what was the manufacturer, when was it installed, who installed it, when does it need to be repaired or replaced, etc. Like I said, those different databases don't necessarily talk to each other. The workflows don't talk to each other, and the programs that they're using, the legacy programs like Agile or Maximo, do not communicate with each other effectively. Thus, the workflows are still based in those legacy programs, and we're not necessarily coordinating our work efforts between different departments because each quote subdivision or subunit is still using the old workflows through the old legacy programs. Another position of where we're at today is that there's multiple owners, meaning the roadway department owns the roadways, the sewer department owns the gravity sewers, the water department owns the water mains. Even though we're all one department, each individual unit has its own priorities in terms of fixing and repairing certain assets that they own and maintain. Here's an example, very common example, Belcher Road at Evans Road. You can see there's a power pole, there's sod that's maintained by the right-of-way maintenance group, there's a stormwater inlet that's maintained by the roadway folks, an ADA ramp which is maintained by the sidewalk control people, a fire hydrant which is maintained by the water department, street signs by the roadway. If any or all of these features needed to be maintained, they would be done currently in our current system through different workflows and different work systems. And those work systems would not be coordinated, so that if I did have to replace the hydrant, for example, the roadway or the ADA crew might be in there. As you can see, the ramp looks brand new. We would be tearing up the brand new ADA ramp to fix the hydrant. If those workflows could be coordinated, then we would fix the hydrant before we built the brand new ADA ramp and thus save the county work effort. Here's kind of an example of the workflow process that we're currently following. Customer service receives a call from a customer or a citizen, there's a pothole in the road. They create a work order and they send that over to the workflow supervisor. Workflow supervisor then gets a crew and figure out who's next in line, and it goes into their queue, which could be several weeks out before they get to that. When they go out there, they say, hey, there's a pothole, we kind of fixed what's there, but there's a bigger problem. There's a pipe failing and the road's going to collapse in 2 years. So then someone has to decide, the supervisor sends that to the engineer, and we come up with an idea, say, well, here's what we really need to fix the problem. We patched the pothole, but how do you fix the roadway? We come up with that solution. Another many weeks go by, the crew makes the repair. Sometimes they report back to the supervisor and the engineer, hey, the repair is done. And then sometimes, even then, that supervisor engineer reports back to the original customer service representative, who then contacts back to the original customer who made the complaint. That is not an efficient process. It would be much better if we could have a process where the customer could find out the status of where his complaint is and what's happening, instead of going through this convoluted process where no one person knows the whole story of what's happening at that location. So what do we want to achieve? And we want to obviously to be more efficient, like I explained. We want to be able to get rid of or combine our legacy work order software programs to one program that everyone has access to and understands. We have to maintain our historical data and leverage that data for future planning, meaning since we already have the historical list of the last 20 years and the work programs associated with replacing certain assets, fire hydrants, stormwater inlets, roadway repave programs, etc., we can't lose that data. We have to keep that data. But then just having the data isn't enough. We need to figure out how to leverage that into creating work plans for the future. And then ultimately saving valuable money and time for our customers and for the taxpayers. GIS is a strategic solution to this problem. What GIS is essentially a smart map, where it's a map that shows all the roads and it'll show a fire hydrant and inlet. But when you go and find that inlet on the map and you click on it, it has an ID number associated to a database that shows all the information that we have historically about that hydrant. And the benefit that the GIS system has is that it can take that hydrant information on the map and geographically associate it next to the stormwater inlet that's owned by a different department, has an entirely different set of data, but geographically it's the same. So it's 5 feet away, it'll show it 5 feet away, and you can physically click then on the stormwater inlet and find all the history of that data. So what that allows you to do is run reports, do planning, et cetera, on an area and know everything about all the assets in that area, as opposed to going to the water department to find out about the inlet, going to the stormwater department to find about the curb, et cetera. So here's an example revisiting that. I kind of explained it previously, but if I needed to repair this hydrant, or if I was going to repair this stormwater inlet, you can say there's already been some paint marks here about a water line that's going to go through here. Knowing that I need to repair this inlet in the future and the water main, I can coordinate those two efforts and perhaps only send out one crew to do both jobs. If I knew that both jobs were required or needed to be done, but the priority or timing was different, I could prioritize one of them, move it up or move it down, and send one crew out to facilitate both repairs at the same time. This does a couple things. One, it's less impactful to the roadway and the people, so that residents don't see us going out and hitting the same spot over and over again. Two, by having one crew do both repairs, it frees up that second crew to go do another needed repair elsewhere in the county. And three, it saves money because we're not digging up the hole twice. And I just went through that really quick, but basically you could move and change the priorities. Also, the crews that are out there, when they have the GIS implemented, would know who owns the different other assets. In case something is damaged, they would know who to go to instead of trying to track it down. Also, the GIS would allow you to alert when certain repairs are done, so the right-of-way maintenance crew would know, hey, I just tore up, this whole area was torn up, I need to come out and resod this, or I need to check it again sooner than my normal work plan because I know it was just work done. Other features that GIS has as a platform is it's able to push out or publish to web portals, meaning that you could publish this information out to the internet that the public could access. It would save phone calls to the customer service because they could go directly to the same apps we're looking at and find out what's happening. And also the engineering modeling that we use to design the water mains and design the storm mains that are their own separate programs that have a bunch of mathematics and engineering involved with the flows and all that stuff. The results of those can be published directly into GIS and all the maps updated immediately. So because those programs talk to each other, it saves the time of rekeying in the results from a modeling solution. A lot of GIS platforms allow real-time update of system assets from field collection devices, meaning I take out my tablet or my phone and I relocate the hydrant using the GPS feature of my cell phone. I can nail the location of the new hydrant and it will automatically update the master database, again saving the time of someone else back in the office keying in the new location. And lastly, GIS platforms allow for way more reporting options and planning across different technical disciplines. Like I explained, the sewer department and the water department and the stormwater department can all plan their activities in coordination with each other. Two different alternatives that I developed here as part of this analysis. One, using an out-of-the-box solution that's already programmed by ESRI or Esri, and there's other Maptitude or ArcView softwares, et cetera, other types of software that are out of the box that do this implementation. Or two, we could hire a consultant to come in and design a system specifically for Pinellas County, and some benefits and risks to those. The way I did that is to prepare what we call a KT analysis, and it analyzes different factors and weights those factors against either option, so that yes, there's lots of things we want and there's certain things we must have, and we weigh those options or those factors against the two alternatives depending on the importance of the factors. There's must factors and want factors, and ideally any alternative we pick will meet all of the must factors and be the most of the wants that we can get. Just some more text about that. This is a summary of the analysis table that I did for these two options. You can see here in my want factors, it must have the existing user interface, learning curve, and how hard is it to learn, how easy is it to publish to the public, how easy is it to upgrade in the future, ease of use for our users, both field people, office people, GIS people, the public using the web portal, et cetera. How compatible is it with the other software packages like I talked about, integrating in different engineering modeling? How compatible is it with a future software upgrade, so that if Microsoft upgrades their Windows, for instance, does that set us back in terms of upgrading our current GIS system? And then what are the technical support costs in terms of keeping the system up and running? And you can see here how the different things are weighted and the rating that each one of these would get, combining a score. And based on this analysis, the out-of-box solution is the clear, better option. But now that we've decided, or I've decided, that the out-of-the-box option is the best alternative, is GIS itself the real solution we need? To do that, I kind of evaluated the benefits and the risk of implementing a GIS. Some of the benefits we talked about: it contains maps, charts, data, all different styles, and it's very easy to report. All disciplines can use it. It's interdisciplinary. It can be published out to customers real time. There's already a ton of free data available from FEMA or DOT or the U.S. Geological Survey or any of the federal agencies, and we can import those data automatically into our maps and create, say, a hurricane evacuation route summary directly from our GIS system, which could also at the same time evaluate stormwater pipes in that hurricane evacuation route, and which are our, quote, critical pipes that must be maintained during a hurricane, for example. And also another benefit, field crews can update our databases real time in the field which is a tremendous time saver and increases the accuracy of our system. There are risks, however. The cost of an implementation. It's not a cheap solution. It's a complete new platform that we have to build, and we're going to have to budget for that. In order for true success to be achieved, all of the stakeholders have to be involved. If the data that we put into the system and we update and maintain is not accurate, then future plans using that data will be irrelevant, frankly. If I want to design a new stormwater inlet, but I'm designing off information that's incorrect, then we've wasted our time and effort. We'll send a crew out there and say the inlet's not even here. There's also a risk that non-effective implementation will just say it's too hard or it's not working, and they'll just go back and devolve back into their old systems and workflows. Lastly, there will be a learning curve, the new software and the new workflow features. Now, it's a known fact that human beings don't like change, especially business process changes. So there will be a learning curve that needs to be continually reinforced. I recommend that we implement the software out of the box as a solution to combine our databases and workflow packages. Using GIS as a platform will have more efficiency. It'll increase work coordination. It'll be better for reporting and record keeping, and it'll definitely a better interface for our customers and responses back to our tax base. However, to effectively implement, we need to mitigate those risks I talked about. So I've come up with a couple recommendations to implement the plan, putting in a GIS system that will reduce the risks. One, we need to prepare our budget ahead of time and then order all of the software and hardware needed, computering, tablets, phones, whatever we need to roll it out at one time. Instead of trying to phase it in, then different people will be on different softwares. It leads to communication, even greater communications problem. It'll lead to frustration with the software that, well, Tommy's still using the so-and-so and it's working better than this new thing. It prevents those kind of problems. We need training classes at least once a quarter to keep employees up to date. And it also allows them a forum to ask questions once they've started using the program and got in depth with it. We should combine those training sessions with different departments so that the water department representative could hear the problem that the stormwater technician is having, and either maybe he may already have a solution for that, or he may hear a solution that he could then apply to him in a future situation that he hasn't encountered yet. And lastly, we need to hold public information sessions to explain to the public why, one, they're paying for this. I mean, they're paying the county to pay for this. And two, what benefit they get out of it in terms of reporting and review of status updates, etc. And that's my presentation. I hope that was informational. I hope that the recommendations make sense. I firmly believe that a GIS platform is the best solution for Pinellas County in terms of asset management and combining our workflows. And I'll welcome any questions at this time. Thank you.